What happens if we take a game like Skyrim, combine it with the original Doom and set it in feudal Japan? That is the premise I started with, and here's how it's going. Now, what do I mean by that? I'm a fan of RPGs like Skyrim and Fallout. I love the open world and the freedom they provide you. Some elements are better than others, but in a whole, the experience allows me to make my own story every time I start a new game. I want to take that and put it in a fantasy setting inspired by feudal Japan. You could be a legendary samurai cutting through hordes of enemies, a ninja wall running and jumping from rooftops, or you can be a full melee monk that punches demons into submission. Wrap it in a retro-looking package, and that is my dream game. Now, where does Doom come in? In this project, I want to lean into arcadey fun gameplay. I want to put realism and sluggish animations aside in favor of fast responsive movement and combat. I don't want to be bogged down by menus or carrying capacity. I want to make an RPG where you can drop in and have a good time as soon as possible. To make my ideas more concise, let's put them in design pillars. This is a list of core elements of my game I can always look back to in order to see if my game is moving in its intended direction or is slipping away. Responsive arcade controls. We have enough RPGs that feel slow. I want to make something that feels fast and more action-oriented while still being an RPG at its core. Freedom. I want the player to be able to express themselves through their character builds and how they interact with the world. Now that means I need to provide them with all the tools needed for that expression. If they want to play a pacifist character that fights with a staff, it's on me to provide them with the tools to do so. Immersion. In addition to atmosphere and freedom, non-intrusive UI is a big contributor to this. UI should be kept to a minimum or be diegetic when possible. The next point can also help us achieve this. Physicality. The world should feel real and interactive. I want items to roll around, catch fire or break. I'm looking at Half-Life and Dark Messiah for inspiration, and I'm considering implementing the same physicality into the combat. I took the FPS controller from the Unity wiki that no longer exists and slapped it onto a plane with some trees. I wanted to see how fun it feels to run around like Naruto. Pretty fun. I went on to create items, weapons, stats, jumping, climbing, and got sidetracked by the cooking mechanic. I shouldn't have done that. I don't even know if I need cooking in my game. I refactored my movement script into a state machine where each state is a component sitting on the player object. I also spent a lot of time on a procedural slicer. After getting it to somewhat work, I realized that it's cool but not a crucial part to the game. It comes with some edge cases that I will have to address in the future, but it will have to wait for now. Another mistake was spending way too much time on the AI. I wanted NPCs to be rigid bodies like the player and move in the same way. This disqualified the built-in character controller. I also wanted the AI to react to objects in its way and, most importantly, other NPCs. I tried a combination of rigid body controls and character controller, where the rigid body follows behind, and a Navmesh obstacle that is being activated and deactivated. I got mixed results. For example, these guys are supposed to be moving in a straight line while avoiding each other. Yeah, I also played around with steering algorithms and composite behaviors, where you can stack many simple behaviors on top of each other to create complex movements. For example, we can have follow component that outputs a vector to our target, and a void component that outputs a vector away from our obstacle, and a cohesion component that outputs a vector towards all nearby flock members. This can create complex and smooth movements, but doesn't really fit human NPCs, since they just sort of slide around. I eventually came to realize that even AAA games use a Navmesh and have funky NPC movements, so I should cut myself some slack. Eventually I settled for the following setup. An AI state machine controls if we are in idle, fight, search or flight. Based on that, it tells the AI input where is our target position and when it should recalculate the path in case the target moved. The AI input activates a Navmesh agent, calculates the path and deactivates it. Then during each frame, it's responsible for getting the direction to our next position along the path and outputs it into input state. At this point it worked the same as for the player. The character state machine gets the input data from input state and moves the entity around, switching between the states as necessary. The only difference between an NPC and a player at this point is that the player has a player controls component that directly writes the input from Unity's input system into the input state. So basically I was using Navmesh with extra steps. A few months passed since I started on this project and it was a mess. Most features were incomplete with long to-do lists ahead. I was jumping between making assets and writing code, and the result was an ugly map. I believed that I was onto something, but without anything tangible people can play, I still needed proof. I had to make an MVP, a minimum viable product. I decided to make a new map with basic textures that is built like a tutorial with designated areas to test each feature in isolation. The lack of graphics and distractions within each area allowed me to focus on finding the bugs and weird behaviors in my existing features. I also made a push to make this playable as soon as possible and gave it to my friends to play. They immediately started finding bugs and abusing the systems. Thanks guys. One of the feedbacks I got regarding the movement is that it felt like you slide on ice. I never noticed this myself, or perhaps I got used to it, but for a fraction of a second after letting go of the controls, the character will slow down to a stop. I played around with the physics material and debugged the input values until I found the issue. I was using getAxis instead of getAxis raw. Basically, that means Unity was working behind the scenes to emulate the joystick slowly returning to its origin, instead of immediately dropping to zero. Another big brain move on my part was trying to make a chargeable jump. The reason was that I want the jump height to scale with your agility stat. At max agility, your jump is very high. But what if you don't want to jump over a building but just over a box? Enter chargeable jump. Hold the jump button and release whenever you want to jump a percentage of your maximum jump height. I thought I was being smart. My friends said, no, just no. So I looked at the king of jumping himself, Mario. Whenever you let go of the jump, you immediately start dropping. As long as you hold it, you continue going up until your jump's maximum height. It still gives you the control over your jump, but feels a lot more natural. I can't say it feels perfect yet, but it's good enough that I could move forward with other features. I made wall running, where the distance traveled on a wall also scales with your agility, and added a dash mechanic where the speed and distance, you guessed it, scales with agility. I added ledge climbing and basic camera animation. I added an area for cooking, which I spent so much time on, and a shooting range. The accuracy and fire rate for ranged weapons scales with dexterity, but the damage scales with strength. I tried different approaches for each weapon, and this is where I'm at. For shuriken, you shoot with the left mouse button and change the formation with the right button. Caltrops can be shot one at a time, or in groups of 6. Grenades work similar to caltrops with single throw or multiple. The bow needs to be loaded first with the R key. You draw back and shoot with the left mouse button and hold the right button to aim and slow down time. You can also load multiple arrows at once for a nice spread. As for melee weapons, the katana is medium range with fast combo. You can chain between the light and heavy attacks using the left and right mouse buttons. You can hold the right button to charge the heavy attack for extra damage. And at max charge you get a slashing projectile that will be reserved for the higher levels or removed if it breaks the balance. I tried a directional katana for a while where you can change its position and attack from that direction. When you guard, you only block attacks coming from that same direction. I found this to be tedious and not really fun, so eventually I scrapped it. I added a staff with similar left and right button combo, where the left button triggers sweeping attacks that can hit multiple enemies. The right button triggers harder attacks that are vertical. While holding R to guard, you can bash your enemies or spam the right button to spin your staff. For unarmed melee, I'm testing a combo mechanic like in fighting games where you need to combine certain inputs to activate special attacks. I would like to expand this in the future with disarms and grappling. If you have any suggestions, please let me know in the comments below, as I am still looking for fun and unique mechanics for each weapon. I added a city area to the prototype to see how the movement will feel in a bigger area. I place shops that spawn pickup items in a grid based on their inventory. To buy the item, you just interact with it and pay automatically. The objective was to make the experience as immersive as possible without any menus. I also think of having a similar mechanic to sell items where you place the weapon in a designated area on the counter and get paid for it. Remember that AI thing from before? It worked. Until it didn't. Apparently Unity does have obstacle avoidance. At least it works better than my code, which has none. And since I deactivate the Navmesh agent after getting the path, I can't enjoy that sweet obstacle avoidance. So forget all that manual path tracking, slap an old Navmesh agent's destination on it as intended, and hey, it's better now. I think it's important for any immersive open world RPG to have a day and night cycle. I made a simple system where I can choose the length of a day in real time and it calculates the speed at which the clock should run. Based on the time value, it interpolates the rotation of a directional light to simulate the rising and setting of the sun. I then added other values like the color of light, color of ambience, and fog color and density to be affected by that. Finally, it translates the time of day to hours based on the 12 zodiac animals. For example, between 9 and 11 AM, it's the hour of the snake. This will tie into the magic system, but more on that in a future video. I also added a basic weather system that generates a random effect every in-game hour. As the amount of systems and variables grew, I needed a way to control them from within the game. I was inspired by Skyrim, Fallout, and Valve games from my childhood, which all have a Debug Console. It's always fun to mess around and it allows me to test in play mode. So far I added commands to set stats, health, stamina, time and weather. It can also activate a GUI representation of info like the active state machine and my current input. And as the game progresses, I will also add ways to spawn NPCs and items. Because I want to be able to play as a ninja, stealth is a big part of the game. I separated this concept into two components: Awareness Agent and Stealth Agent. Awareness Agent is responsible for detecting the stealth agents with vision or registering the position of the sound created by them. I eventually came up with the following solution for the vision check. You cast a sphere and find all agents in its area. For every agent you check if it's within your required horizontal and vertical angles. You then raycast to make sure nothing is blocking your line of sight. The raycast goes between one agent's eye level to the other and not to the center of the object. This helps clarity since if you see the enemy you know it can see you. You then add all valid targets to a dictionary of almost visible, where you slowly increase your awareness of each one of them until they become fully visible. When they are fully visible, they are added to a dictionary of visible targets. Every frame you verify the almost visible targets are still in your line of sight, to either reduce your awareness of them or remove them completely. You also check the visible list every frame and remove them once they are no longer visible. So what's next? The game is still in a very early stage, a lot of systems are missing and the combat is not what I'd want it to be. Still, if you want to give it a try, head over to the link in the description. If you have any suggestion on how I can improve, let me know in the comments. What I am working on now is a bigger demo that will capture more closely the final experience I want for this game. What I currently have is this, a shallow representation of the functionality. The next big step for me will be to create this, which is a vertical slice of all the elements that make a good game. The combat needs to be more engaging, skill trees need to be designed and implemented, an aesthetic needs to be chosen, and much more. I am already working on some of these elements even if I decided to leave them out of the prototype. Stay tuned for future videos on my progress with that.